Welcome back to question 4, and I think this is a very interesting question which we can learn a lot from, because we're going to do question 3 again, but we're going to pretend we do not know the population variance. I'm going to do a side-by-side comparison. I'm going to leave the left side for the working for question 3, and I'm going to use the right side to show you the working for question 4 from step 0 all the way to step 4. And I'm going to use red ink specifically on what has changed in question 4 when we do not know the population variance. So with that, let's get started with step 0. Welcome back. Let's collect some information before we get started. Perhaps the most obvious difference is we do not know the population variance now, and because we do not know the population variance, this is no longer not required. We need to know what is our sample variance in order to work out what is our estimator S squared. So you can think of the estimator S squared as the next best guess to what sigma squared is. But some of you who are more advanced in your revision, you're preparing for prelims or A levels, you know that we do not need to work out what this is explicitly. The formula in your MF26 states that this is just 1 over m minus 1 times of summation of x squared values minus the square or summation of x over n, and is exactly this one that we're going to use because I'm going to skip over finding the sample variance. Let's move on to the next part of step 0. So the working in yellow, it remains the same, and if you follow the formula in MF26, which is this, let me just pull up the graphing calculator to show you. It's also at this step that I very heavily recommend that you save this answer as an alphabet in your graphing calculator. To do that, you go to the store button. It is just above the on button, and click on alpha and choose any letter you want. I'm going to choose A. A is the math button. Press enter, and this will be stored because we're going to need to call on this value, especially when we use the graphing calculator to do the z-test. With this, we are done with step 0. It's a bit more complicated than before, but it's nothing that we cannot handle. Let's look at step 1. Welcome back to step 1. This is going to be short because step 1 is exactly the same. Nothing has changed. So let's move on to step 2. So under step 2, we are going to start the test proper by assuming that the population mean is indeed 1.5. We can say our sampling mean variable follows a normal distribution with expectation of 1.5, and this is now replaced, instead of sigma squared, this is replaced with a s squared. And over here, when we are converting to our z variable, we're going to also replace our sigma with a letter s. And that is step 2. Now let's look at step 3a. How can we conduct the test using the z-test statistic and the critical region? Welcome back to step 3a. And in question 4, the only thing we changed is from sigma to small letter s, and this is our new test statistic, z. Now the critical region is still the same because that is defined by the level of significance, which is 1% in this question. Let's draw a quick sketch to see whether or not we should reject h0. For question 4, it is also outside. It is nearer now to the critical value, but it's still outside the critical region, which means the conclusion remains the same. We will not reject h0. Let's look at step 3b. How can we conduct the hypothesis test using a graphing calculator to get the p-value? To obtain the p-value, first you need to assess your z-test, and under stats, let's key in these values. For mu0, it's still the same. The population mean assumed under h0, 1.5. For sigma, we're going to have to estimate it using s, not s squared. So that will be the square root of our stored value a. And just simply press down. The calculator will calculate it for you. X bar is 1.475. Our sample size is still 40. Okay, we're testing for less than population mean, and let's calculate. When you press enter, you will see this is the p-value that we obtained. Let's look at our concluding statements. So in step 4, the concluding statements are exactly the same as question 3. Now you can either say that the test statistic falls outside the critical region, or you can say that p-value is greater than the level of significance. Therefore, we do not reject h0 at 1% level of significance. There is insufficient evidence to conclude the bottles are underfilled. So that concludes question 4. I hope you found this helpful. Next, we're going to look at question 5, another different type of question where we have to fill in data into a list. We're going to use our z-test in our GC. Instead of using the stats part, we're going to use the data part. Stick around, I'll catch you on the flip flop.